Welcome back, all of you, to the third session of the video lecture series on water chemistry and sewage water treatment. Glad to know that you're all following the classes and enjoying the classes too. Thank you for the feedbacks. Hope you will enjoy this session too. The syllabus, as I said, has been divided into 8 parts, and today we will be seeing estimation of hardness, the EDTA method. This is one session that includes theoretical part as well as numerical part. So get ready for the tutorial session also. Welcome to Water Part 3. Estimation of hardness by EDTA titration method. And please note that this is a frequently asked question in the KQ examination. Now let's see what EDTA is. It is ethylene diamine tetraacetic acid. It's nothing but a substituted ethylene diamine, as you can see here from the molecular formula. Ethylene diamine, we all know it is CH2CH2 with amino groups on either side, NH2, NH2. And here, the hydrogen atoms on the amino group, on the NH2 group, are substituted by CH2COH, CH2COH on either side. So, 4 hydrogen atoms, 2 on one NH2, 2 on the other NH2, all the 4 are substituted by CH2COH. See here. Okay, so this is the structure of EDTA. Now let's move on to the procedure. Well, about the EDTA titration, let me introduce this as an accurate and a convenient method. This is called a complexometric titration method because this involves the formation of 2 complexes. One with EDTA, which is used as the titrant, and the other with the indicator eriochrome black tea, which is used as the indicator. EDTA is colorless, whereas the indicator EBT is blue in color. Both these have the ability to form complexes with the metal ions present in the water. And the metal ions commonly present in hard water are magnesium or calcium. Well, the principle involves the formation of the 2 complexes we just mentioned. First, let us consider the complex between the indicator EBT and the metal ions present in the hard water. Usually, they will be magnesium ions or calcium ions. As per this equation, the complex is formed. You can see the metal ions plus EBT forming MEBT complex. Now, the colors are very important here. EBT is blue in color, whereas the complex that is formed is wine red in color, and also it is relatively unstable. Now please note that for the indicator EBT to be functional, the pH has to be an alkaline pH of around 10. And how do we provide that pH? By adding a few ml of ammonia, ammonium chloride buffer solution. So this is the first complex. Now, when the titration starts, the titration is against EDTA titrant taken in the burette. Now what happens? EDTA is also capable of forming a complex with the same metal ions present in the hard water at around pH 10. So as per this equation, a reaction occurs. EDTA in fact decomposes the MEBT complex and it takes away the metal ions forming MEDTA complex, liberating the indicator EBT free. Now what is peculiar about MEDTA complex? It is colorless and it is stable. EDTA, please note, is a hexadentate complexing agent. So this is the reaction happens during the titration. And please note the end point is a sudden color change from wine red to blue. Before we start the titrations, let us have a look at the reagents and also the possible titrations involved. The reagents are mainly the indicator EBT, the buffer solution for providing the pH, and the EDTA, the titrant, the one which is taken in the burette. And the possible titrations involved here are EDTA versus standard hard water, EDTA versus sample hard water, and EDTA versus boiled hard water. Now, EDTA method involves, in fact, a series of titrations. But luckily, the procedure for all these is common. So let us have a look at this general procedure. First, we take the hard water in a conical flask. A measured quantity, a non-volume, say around 50 ml of the hard water is taken in the conical flask. The hard water can be standard hard water, sample hard water, or boiled hard water as the case may be. We will be coming across all these three kinds of titrations later. Now, after taking the hard water, what do? We add 5 ml of ammonium chloride buffer solution for providing the pH 10. Then we add 2 to 3 drops of the blue colored eriochrome black tea to it. What happens then? It forms the MEBT complex, which is wine red in color. Now the content of the conical flask is ready for titration. We take EDTA in the burette and start the titration. Now what does EDTA do? EDTA also forms the complex MEDTA complex at pH 10. As per this equation, MEBTA complex plus EDTA giving MEDTA complex, liberating the blue colored indicator free. We have already discussed this in the principle. Now, the end point will be a color change from wine red to blue. I have added this slide just for you to appreciate the color changes. In the first one, you can see the wine red MEBT complex before the titration. Now, once the titration starts, the color slowly changes to blue. This is somewhere near the end point, towards the end of the titration, the transition stage. Now here you can see the clear end point. The wine red has totally converted to blue color, changed to blue color. Calculation of total hardness. That is, a sample water is given to you and you are asked to find out the total hardness. How do we find that? For that, we need to find the concentration of the hardness producing salt in it. That is, let us say C sample. How to find C sample? We are going to titrate the sample solution against EDTA and then we are going to apply this in the normal titration equation and going to find out C sample. So we take sample hard water and it is titrated against EDTA. The same procedure which we have seen in the previous slide is repeated here. 50 ml of sample hard water is taken, ammoniacal buffer is added, few drops of EBT indicator is added, then wine red complex is formed. It is then titrated against EDTA. And at the end point, there would be a color change from wine red to blue and then the titer value is noted. The titer value means the volume of EDTA consumed. So we know the volume of the sample hard water, but we do not know the concentration. But we know the volume of EDTA, that is a titer value. And if you know the concentration of EDTA, then you can easily find concentration of sample hard water. How? Through this equation, V1 C1 is equal to V2 C2. Let us translate it to this situation. It is like V sample into C sample is equal to V EDTA into C EDTA. We know V sample, we know V EDTA, that is the titer value, and if we know C EDTA, we can easily find C sample. C sample is given by rearranging this equation. Now, once we know the value of C sample, the unit will be in milligrams per milliliters. But we express the hardness in milligrams per liter. So we need to multiply further the C sample by 1000. Total hardness would be C sample into 1000 milligrams per liter or ppm. The same procedure is followed in all other cases also. Calculation of total hardness. For finding total hardness, we take sample hard water and it is titrated against EDTA through the same procedure. That is 50 ml of the sample hard water is taken in the conical flask, 5 ml of buffer solution is added, 2-3 drops of the indicator is added. We get a wine red colored complex. Then we titrate it against EDTA, and at the end point we get a color change from wine red to blue. Then we note the volume of EDTA. Like any other titration, the equation here also V1C1 is equal to V2C2, or here it would be V sample into C sample is equal to V EDTA into C EDTA. From this we can find the concentration of the sample hard water, that is C EDTA into V EDTA divided by V sample. But the unit will be in milligrams per ml. We need to convert that into milligrams per liter. How do we do that? By multiplying by 1000 and you directly get the total hardness. C sample into 1000, total hardness in milligrams per liter or ppm. Okay, so this is how you find the total hardness, and in a similar way we can find the permanent hardness also. Let us see. Calculation of permanent hardness. Here, the only difference from the previous one is that we are using boiled hard water in the place of sample hard water. That is, we are boiling the sample hard water, then cooling it, and then measure a specific quantity like 50 ml of the boiled cooled water to be exact, and then titrating against EDTA. Now, why are we boiling? When we boil, what type of hardness is removed? We know it is temporary. Or let me put it this way. In boiled water, which type of hardness stays, is retained, or is present? That is permanent hardness. So by titrating boiled water, we can find permanent hardness. That is the idea. Boiled hard water against EDTA. The same procedure, 50 ml of boiled cooled hard water is taken, and buffer is added, indicator is added, wine red complex is formed, titrated against EDTA. At the end point, there would be a color change from wine red to blue, and the volume of the EDTA is noted here also, and that would be VEDTA, that titer value. And we apply that in this equation. V boiled, we know. VEDTA, we know. If we know the value of CEDTA, then we can find out C boiled. And once we know C boiled, multiply it by 1000 and directly find the permanent hardness. It's simple. It's nothing but a repetition of the previous step. Now on to temporary hardness. It's very easy. We already know total hardness and the permanent hardness. You just subtract the permanent hardness from total hardness and you directly get the temporary hardness. Now please note that it is not necessary that the CEDTA value is known to us, is given already. In such cases, we will have to find out CEDTA, concentration of EDTA. Or let us say we need to standardize the EDTA solution given. How do you standardize it? We standardize EDTA by titrating it against hard water. What kind of hard water? A standard hard water whose concentration is already known to us. So, how can we prepare standard hard water? It's easy. We weigh an amount of calcium carbonate, dissolve in HCl, and then dilute it to a certain volume. If W is the calcium carbonate, mass of the calcium carbonate, and V is the volume of water used, then C standard is given by W by V. I repeat,
W is the mass of the calcium carbonate and V is the volume of distilled water used for preparing the standard hard water. And then C standard is given by this equation. Now the standard hard water is ready. Take 50 ml of the standard hard water and titrate it against the EDTA given. EDTA versus standard hard water. In a similar manner, that is, we add ammoniacal buffer, then the indicator, we get a wine red color complex in it, and then we titrate it against EDTA. The endpoint would be wine red to blue color, and we note the VEDTA. CEDTA is not known to us, and we apply it in this equation. VEDTA is known to us, CEDTA is unknown, and that is equal to V standard, we know that 50 ml, and C standard, we know that how W by V. So everything except CEDTA is known to us. You can easily find CEDTA. So if CEDTA is not given earlier, we will have to find out CEDTA in this step.
So let's now take a quick review of the points we have seen. And for the time being, please assume that you do not know the value of CEDTA. It is not given. Then we need to standardize EDTA solution first, and for that, we have to start from the preparation of the standard hard water. Preparation of standard hard water. Second step, standardization of EDTA. Third step, estimation of total hardness. Fourth step, estimation of permanent hardness. And fifth step, estimation of temporary hardness. Now remember, standardization of EDTA by standard hard water versus EDTA, total hardness by sample hard water versus EDTA, estimation of permanent hardness by boiled hard water versus EDTA. Now let's take a detailed review. C standard is given by W by V. That is how we prepare the standard hard water. Then how do we find CEDTA? CEDTA is by this equation. CEDTA is equal to V standard into C standard by VEDTA. Well, before we move on to the tutorial, I have cited here a few questions which have appeared in the K2 examination. And of course, it's a procedure of EDTA titration. Please note, this is a repeatedly asked question. And then the role of ammonium chloride buffer, another one on the indicator, how does it act? All these are included in the study material provided to you also. Then please prepare well.
Tutorial 5.2, that is the second tutorial of module 5.
Before we start the sums, let us try to make them easy. Here are a few tips. First one, remember these steps in order. This is a repetition of a previous slide, but very important. C standard by this equation, W by V, where W is the mass of the hardness producing salt and V is the volume of water. Then to find CEDTA, we standard hard water, C. V standard into C standard by VEDTA. Then the next one is to find total hardness, and standard is replaced by sample hard water. And C sample is found by CEDTA into VEDTA by V sample. And it is usually obtained in milligrams per ml. If it is so, then multiply by 1000 for finding the total hardness. Similarly, permanent hardness, C boiled, CEDTA into VEDTA by V boiled. Permanent hardness is given by C boiled into 1000. And finally, temporary hardness given by the difference between total hardness and permanent hardness. Now the next point is, what if the concentration is given in molarity instead of milligrams per ml? Well, if it is in molarity, the equation becomes V sample into M sample, not C sample, M sample, and that is equal to V EDTA into M EDTA. M stands for the molarity. And we find M sample by rearranging this equation. Well, here let me tell you, so far in this discussion, we found C sample which was expressed in milligrams per ml. That is the reason why we multiplied it by 1000 to get the total hardness. But here it is in molarity. If it is in molarity instead of milligrams per ml, then you can find the hardness by multiplying it with 10 raised to 5, not 1000. M sample into 10 raised to 5 will give you the total hardness. Similarly, in fact, this we have already covered in one of the earlier video sessions, so I'm not going into the details. Please refer to that. And suppose the concentration is in normality, as we have seen in the earlier sessions, it would be nothing but N sample by 2 into 10 raised to 5 again. Okay. Now, one more point is there, and that is not related to this one. Please bear in mind this last point. 1 gram per liter is exactly equal to 1 milligram per ml. So sometimes it will be given in grams per liter. Then if it is 5 grams per liter, that would be exactly 5 milligrams per ml. Okay, now let us move on.
Let's start with a very simple question of finding C standard. What is the equation? C standard is equal to W by V, where W is the mass of the hardness producing salt used for preparing standard hard water, and V is the volume of the distilled water. Usually the salt would be calcium carbonate. Let's move on to the example. In a hardness experiment, the standard hard water was prepared by dissolving 10 grams of calcium carbonate in dilute HCl and making it up to 1 liter. Find C standard. So what is W here? W is 10 grams, and what is volume here? Volume is 1 liter. Just substitute. C standard is equal to W by V. W is 10 grams. V is 1 liter. C standard would be 10 by 1 grams per liter. Now we already know 1 gram per liter is exactly equal to 1 milligrams per ml. So directly we can convert that 10 milligrams per liter. Isn't it simple? So let us try another question. For preparing standard hard water, 0.5 grams of calcium carbonate was dissolved in HCl and the solution was made up to 500 ml. Fine. Find the C standard. How do you do this? C standard is equal to W by V. Here W is 0.5 grams and V is 500 ml. Substitute 0.5 gram divided by 500 ml. But the problem here is one is in grams and the other is in ml. We need to convert both into milli units. So 500 by multiplying by 1000, we get converted grams into milligrams. 500 milligrams divided by 500 ml. I hope this point is clear. 0.5 grams into 1000 will give you 500 milligrams. We are converting grams into milligrams. Okay. And milligrams, we need the final answer in milligrams per ml. So this is 500 by 500, that is 1 milligrams per ml. Or you can also express it in terms of grams per liter, 1 grams per liter.
Now I hope you are ready for moving on to more complex ones involving the estimation of hardness. Here is one. In an experiment to determine the hardness of the sample hard water, please listen. 1 gram of calcium carbonate was dissolved in HCl and the solution was made up to 1 liter. Standard hard water, C standard is W by V, 1 gram per liter. Okay, let us read. With distilled water and 50 ml of this solution required 25 ml of EDTA. Standard hard water against EDTA. 100 ml of the sample hard water required 20 ml of EDTA. Find the hardness, total hardness. There is a second part to this question. After boiling, boiled water is used for permanent hardness. Well, after boiling 100 ml of the hard water, used up 11 ml of EDTA. The question is to calculate permanent hardness as well as temporary hardness. Well, read the question carefully and do it by yourself. Try to do it by yourself. And once you do, we will move on to the next slide and check your answer.
Just what I have said earlier. To find C standard, we are substituting W by V. W, we know it is 1 gram from the question, 1 liter. V, so 1 gram per liter, that is exactly equal to 1 milligram per ml. So C standard is ready. Now we need to find CEDTA. For CEDTA, we know V standard is 50 ml. V EDTA for the titration, which is given in the question, 25 ml. And CEDTA is found using this equation, which is 50 into 1 by 25. 50 is V standard. C standard is 1 here from this, and 25 ml is VEDTA. So we get it as 2 milligrams per ml. And now the next step is to find the total hardness. And for that, we need to consider the sample versus EDTA. So here V sample is 100 ml. It is in the question. VEDTA is 20 ml. That is also given in the question. We need CEDTA. CEDTA we have already found here in the previous step. So we can just substitute here and we get it as 2 into 20. 2 is the CEDTA. 2 into 20 by 100. Just direct substitution and you get it as 0.4 milligrams per ml. Now multiply by 1000 for finding the total hardness. So that is 400 milligrams per liter and that is 400 ppm. Now to find the permanent hardness, and that is boiled water. Using boiled water, it is given in the question that V boiled is 100 ml and VEDTA is 11 ml. That is also given in the question. We already know CEDTA. What is that? 2 milligrams per ml. In the second step, we have found out. So we can easily substitute 2 into 11 by 100. It is 0.22, or into 1000, we will get the permanent hardness, and that is 220 ppm. And then we can find the temporary hardness by taking the difference, 400 total minus permanent. 400 minus 220, and that is 180 ppm. So in a similar way, you can do many sums. I will be giving you a few questions here. Please do it by yourself. And this is a sample question. Here is one question which I would like you people to do by yourself as a homework. So in this question, carefully read this and please don't get confused with different volumes of EDTA. Here I have shown in blue color all the EDTA volumes. In the first titration, that is standard hard water, it is 28 ml EDTA. And the titration with sample hard water, it is 20 ml of EDTA. And in the titration with boiled water, it is 11 ml of EDTA. So please make sure that you are not getting mixed up with all these volumes of EDTA. That is one thing you have to bear in mind while doing the EDTA sums. Okay.
This is one question in which the concentration is expressed in molarity instead of milligrams per ml. That is why I thought of doing it for you. Listen here. A 100 ml sample of water on EDTA titration with EBT as indicator consumed to 50 ml of 0.025 molar EDTA till the end point is reached. Calculate the hardness. So we have to switch to this equation. V sample into M sample is equal to V EDTA into M EDTA. So M sample is found and substituting the values, we get it as this. And then how do we find the total hardness? M sample into 10 raised to 5. Just remember that. And then we find the total hardness. Suppose it is in normality N sample, then N sample by 2 into 10 raised to 5. That's it. Now I'm going to give you a few questions. So we are coming to the end of the session here. For you to do later, I have added at least 8 questions. Make sure you're doing them, all of them for your reference. I've added the answers also. And take your own time, but make sure that you are doing them. I hope you enjoyed the session. Wait for more and we will meet soon in the next session. Thank you so much. Take care all of you. Stay safe, stay home.